Okay, welcome back, mathematicians, and today we're continuing on our theme of the circle. So, you might like to imagine yourself, coming across some sort of a circle that you need to, we need to know the area of it. It could be a solar flare in our solar system, and you're a mathematician working at NASA to keep a record of these things. You could be designing a piece of clothing and need to measure some fabric and know the area of a circle. Could be anything. So, what do we have here? So we know that the link between the perimeter of a circle and its radius has challenged civilizations for thousands of years. So, there's a bit of a funny equation there of what people used to think it might be. So with some mathematicians used to, I suppose, play around with adding different sorts of triangles and squares and shapes and different things into circles to try and figure out the area of a circle. Another way that mathematicians may have done this was by actually, in the very centre of the circle, putting a dot, then cutting out all these triangles around it, and then laying them into lengths like this, and then looking at the calculating the area by using the length times width. And if you did this, you would find that it is actually surprisingly close to using the real equation. Alright, so let's jump straight into it. So here's some important things that we need to know. So the ratio of the area of a circle to the square of its radius is equal to pi. Okay, what does that mean? So, for example, that is, if you divide area divided by the radius squared, that is how you get pi. So, therefore, when you rearrange this equation, which we may have looked at already, or you may know that if you can actually rearrange in the equation. So we can actually get area by itself on the left here, and then pi r squared on the right by itself. So here we have how the equation of the area of a circle is found. So to find the area of a circle, you would use area equals pi r squared. Now, we will look at that in a moment. So half a circle is called a semicircle. Here you go, nice picture of half a circle. We have r here and a nice straight line for the diameter. To find half the circle, you may have already guessed that you just whack a half in front of pi r squared, and that's how you get the area. Now, you've probably already guessed it, but I'll get it out of the way if I can. So, try and guess what a quarter of the circle, what equation you would use to calculate that. You guessed it, a quarter times pi r squared. What do you think? Pretty straightforward? Sorry, I couldn't resist. Okay, so finding the circle without technology can prove quite technical, as we can't obviously use the infinite number of decimal points that are in pi. So we need to give pi a value, a specific value. So for example, if pi equaled 22 over 7, which is, 3.14, or if pi equals 3.14, so as a fraction or as a decimal, how would we do that? Alright, here we go. So let's look at the first one. I'll whack it over on the right here. So, we know that our radius is 7 meters. Without even looking at the question, let's start to identify what we've got. So we've got 7 meters. We know that pi is going to equal 22 over 7. What else do we know? That's pretty much it. We know that we have the equation area of a circle is pi r squared. So my question to you is, do we have everything we need to solve this equation? The answer is yes. Okay, area equals pi. What we do know, I'm putting in red, pi times 7. 7 being the radius, so we get that. Whack it in there. 7, and we also need to make that squared. When we whack that into our calculator, we get the answer of 154. Don't forget your units of measurement. It's in meters squared. Now, all areas, unless it's a three-dimensional shape, but for two-dimensional shapes, are measured in squares. So let's go to the next question. So our next question here is pi. Find the area of this one. There you go. Area. We know that area equals pi r squared. We've got our r, we've got our pi, we're good to go. Area equals pi times 10 squared, which is essentially 3.14 times 10 squared. If we split this up, we would have 3.14 times, what's 10 times 10? 100. Now, who can remember the law or the rule of when we're timesing our fractions by 100? We simply just need to move the decimal point across. Now, how do we know how many decimal points to go or which direction to go? If we're timesing, we move to the right, and we just count the number of zeros. We've got 1, 2. So, the decimal point simply moves 2 spaces to the right, so we're left with 314. Now, let's check my answer. It will be very embarrassing if it's wrong. There we go. So, area equals pi r squared. Now, look what I've forgotten to put in. My units of measurement, centimetres squared. So I feel like I need to go back and add that in. 314. Oops. Centimetres squared. Alright guys, so now we're on to finding circle areas using the calculator. Okay, here we've got our circle, we've got our radius. Do we have our pi? Well, we're using our calculator, so this is essentially what we're going to use. So we've got our radius, which is 2. Pi, we're ready to go. Area equals pi times 2. R squared, sorry. Area equals pi times r squared. Area therefore equals pi times 2 squared. Remembering that our 2 is the radius, which is that number just there. And we're squaring that, so essentially 2 squared, I'll put it over here, is 2 by itself, times by itself, twice, so 2 times 2. And we get our answer of 12.57 centimetres squared. Alright, so we're nearly there with this one. So finding areas of semicircles and quadrants. Here we have a semicircle, which is actually a quarter of a circle. So I'm going to put a quarter there already. Now, if we can remember back to before, we read that to find the area of a quarter of a circle, we just simply put the quarter at the front and times it by pi squared. Now, if you've got half a circle, we put a half at the front and go pi squared. Now, depending on what r is, here's our r goes there, whack that into your calculator. Here's, wow, actually this isn't an r, this is a diameter, so we need to actually use half of 5 kilometres. I'll write it up here, so our diameter is actually 5. Now we want our r. Now r is half the diameter, so half of 2.5 is, half of 5 is 2.5, sorry I gave it away. So this is actually our radius. So what does that look like? Let's move down to here. So let's look at this one. So here we have area of our quadrant equals 1/4 times pi r squared. And remember our r is just here, which is 3. So 1/4 times pi times 3 squared, which gives us 7.07 metres squared. Now we'll look at the next one. So remember, we have our semicircle, which looks like this. Our diameter was 5. We found that our radius was 2.5, so we can then use this value and pop it into our equation. So half times pi times 2.5 squared equals 9.82 kilometres. Alright, so what I want you to do is to tackle a few of these questions, maybe starting with these ones, questions 1, 2 and 3. Alright, ready, set, go. Thanks for listening, guys. This is Mr. Rubin. Happy mathematics.